Okay, in today's video, I'd like to talk about pyramids, lightning rods, and capacitors, and how everything's actually working in nature. Okay. In order to produce this condition that you see here of lightning or electricity, you need two things. You need magnetism and you need dielectricity. Magnetism and dielectricity are also known as the ether. Okay? When you have those two conditions present, you can produce a third condition called electricity. Okay? A cloud is working the same way a capacitor is working. It's building up and storing the charge in the cloud, and then it's discharging. So lightning is actually a dielectric discharge. It's nothing other than, it's the same exact thing as an electrostatic discharge. Just like when you drag your feet across the carpet and you discharge and a spark comes out, okay? It's the same thing. Same exact thing. So a pyramid is just a dielectric capacitor, meaning it builds up the charge and it stores it in the dielectric material. Okay, a material is very important. Okay. So first let's get into lightning rods. A lightning rod functions just like a pyramid functions because of its geometry. It was thought that lightning rods actually work one way, but we found out later on that they work another way. Lightning rods work because of the pointiness, okay? That pointiness is the attractor and draws in that dielectric discharge. Okay, just like an antenna. It's not the material, it's the pointiness of the material. This is a fairly recent discovery. Okay, and a pyramid is the same exact way. It's the pointiness at the top where all of the flux is. In a magnetic pyramid, you can take a pyramidal magnet and all the flux is streaming from the top. Okay, it's the focal point. And it's the same with this stone pyramid here, with this concrete pyramid. Okay, it's nothing different. And I'm going to show you right now how it's working. Because in a lightning rod, they thought that it was always because the rod was metal. And that was drawn in the lightning. But that's not the case. It's the pointiness of the object. Okay. We need to look at a couple terms here first to explain this. The first term is dielectric. So this isn't something that's made up. This is something that's been in the vocabulary since the 1800s. People have known all about this. Okay, it's just been forgotten how it actually functions. And the physicists have convoluted electricity so bad that you can't even understand what electricity is. So let me try to explain this. Okay. Dielectric. A dielectric is an electric insulator. Okay. And the other term we want to look at right now is the dielectric constant. The dielectric constant is a method of determining the insulation properties of a dielectric using air as a reference. Okay, what does that mean? When this pyramid is sitting on the earth, okay, it's using the magnetic field from the earth and the dielectric field from the air. Okay, so you have the two conditions present for electricity. You have the magnetism and you have the dielectricity. Okay. In the ether, in the air around this pyramid, there's something called the K dielectric value of the air. Okay, that's what that term was talking about. The K dielectric value of the air is 1.006. So everywhere around this thing, there's a K dielectric value of 1.006. Okay, so that's always present. Okay, that's like a baseline. Remember, you need two things to produce this. You need magnetism and you need dielectricity. Okay? Magnetism from the earth, dielectricity from the air. The conditions are present. Okay, this is what we're going to go into next. Dielectric constant. Okay. Different materials are assigned a different number, okay, called the dielectric constant. Okay, so in this chart, it shows you the material and then it shows you the dielectric constant number. Okay, this is very important. Okay, like I said before, air on this chart has a dielectric constant value of 1.006. Okay, it's low, but it's present. Okay, now a really, really super good dielectric material, the highest one on the chart is ceramic. Okay, everything else on this chart is 1, 4, 7, 8, 9, 90 to 170. Okay, the ceramic material blows everything else out of this chart out of the water at 1200. Okay, so this is important because a ceramic is a super good insulative material, right? It takes a lot to get it hot, and it stays cool. So it's a good insulator. Okay, it's the same thing with stone or with concrete. Okay, this is a super, super high dielectric material. Okay, that electrostatic charge can be stored in the material, like I said, and then released. Okay, and it talks about it here. It says, the energy of the capacitor is stored in the dielectric in the form of an electrostatic charge. Okay. So this thing is functioning exactly like a capacitor. It's storing up the charge in the dielectric material and it's able to release it. Just like an electrostatic discharge of lightning. A lot has to do with this shape. It's got everything to do with the shape of the material. Okay, the pointiness of the object, just like that lightning rod. The pointiness of it is what attracts the dielectric discharge to occur. Because it's all about geometry. Okay, now think about this. This object is sitting in the ether at all times. Okay, so it's no different than a flowing stream, and you put a stick in the flowing stream. When you do that, you change the flow of the water around the stick. Okay? When you put an object with this geometry and the pointiness into the ether, you're changing the way that the ether is flowing all the way around this object. You just put this shape, this wedge, into the ether, and it's changing the flow, the stream of the ether around the object. So the atmosphere in this area, in the presence of that object, it's all going to be changed. It's not going to be the same. Okay? So that's how this thing's working. So while the pyramid it's not sitting stationary, it's sitting on the earth. So the earth is revolving and spinning over 1,000 miles an hour, okay, through the ether. So this thing is always gathering charge, because it's never in a static state. It's always moving. To you, it might look like all those three pyramids, on the Giza Strip are just sitting there. But guess what? Those things are rotating over 1,000 miles an hour through the ether. So all the conditions are present for this. You have your magnetic from the earth, you have your dielectric from the air. It's always present. And it's running through every single object. It penetrates everything. That's how the pyramid is functioning. It's functioning as a dielectric capacitor. It's able to hold and store an electrostatic charge because of its material. Thanks for watching.